Hello and welcome. My name is Ognjen Petrovic and I'm an applications engineer at Typhoon Hill. In this tutorial, we'll be going through a new group of components that enhance the flexibility of Ethernet communication with your Hill device, included in the 2025.1 software release of Typhoon Hill Control Center. With this software release, you can implement now custom protocols based on either Transmission Control Protocol, TCP for short, or User Datagram Protocol, better known as UDP, enabling them to run seamlessly on any Hill device. Both protocols operate as bare metal applications with a guaranteed deterministic execution rate and are supported on all Hill devices. With the new additions, you'll experience greater flexibility for implementing and testing custom protocols tailored to your need. Additionally, flexible Ethernet communication offers scalability, allowing for multiple send-receive components to be configured independently. Finally, integration with third-party systems has become easier thanks to improved debugging and monitoring capabilities, as well as enhanced adaptability for various network architectures. You can access these components by navigating to the Ethernet communication section of the communication category in the core library of the schematic editor. You can easily drag and drop them onto your schematic for quick integration. As mentioned before, TCP is connection-oriented, meaning the sender and receiver first need to establish a connection based on agreed parameters. These parameters are determined in the component's property windows. Connection is done through a three-way handshake procedure. The server must be listening for connection requests from clients before a connection can be established. The three-way handshake, retransmission, and error detection enhance reliability but also increase latency. There are two new components under the TCP subsection of the Ethernet communication. Those are TCP send and TCP receive component. TCP send represents a client. The client is easily defined through its IP address and net mask. You can also specify the local port of the client from which data will be streamed. The client tries to connect to the remote server specified by destination IP address and destination port after the simulation starts. If the server is accessible, an active connection is opened, system variables are packed and transferred over Ethernet. Port selection is available through the Ethernet port property. The component has three ports. One is for data, one is for length of the last message, and one is for status, which indicates how many messages have not been sent for any reason. TCP receive represents a server with a passive open connection. It waits for any client to try to connect. The server is easily defined through its IP address and net mask. You can also specify the local port of the server on which data will be received. If specify source port and specify source IP address are deactivated, the server is configured to accept an incoming connection from any client IP and port. By enabling the specify source port and specify source IP address checkboxes, TCP receive component can also be configured to accept an incoming connection only from a specific IP and a specific port. After the connection has been accepted, the server starts receiving packets. TCP receive component has four ports. One is for data, one is for a length of the last received message, one is for the number of received messages since the beginning of the simulation, and one is for status, which indicates how many messages have not been sent for any reason whatsoever. As an example, let's simulate a server on the Hill device while running the client from an external Python script on the PC. For this application, we are using a TCP receive component. Let me show you how this is set up. The IP address refers to the server, and the source IP address is left unspecified. We've added probes to the schematic to monitor key outputs like status, data, message count, and number of received bytes. The data signal represents the memory addresses where all the data is stored. After compiling the model and opening the SCADA panel, we can monitor the outputs using digital display widgets. Once we start the simulation and run the external Python script, a connection is established. Now, in the SCADA panel, we are able to follow the number of messages received since the simulation has started, and how many messages have not been sent for any reason. If your application requires communication with clients and servers on different local send-receive ports, you can achieve this by including multiple instances of TCP send and TCP receive components. Applications that don't require reliable data streams typically use the User Datagram Protocol, UDP for short, a connectionless protocol that prioritizes speed over reliability. UDP sends messages without establishing a connection and doesn't track what it has sent. It provides checksums for data integrity and port numbers for addressing different functions at the source and destination. Without handshaking dialogues, UDP exposes the user's program to any network unreliability. It is often used in applications where error checking and correction are either unnecessary or handled at the application level. The Ethernet UDP category consists of three new components. Those are UDP send, UDP receive, and UDP multicast receive. UDP send represents a client. The client tries to connect to the remote server specified by destination IP address and destination port after the simulation starts. If the server is accessible, an active connection is opened, system variables are packed and transferred over Ethernet. UDP send has three ports, and they are the same as the ones in TCP send component. UDP receive represents a server with a passive opened connection. It waits for any client to try to connect. The server can be configured to accept an incoming connection from any client IP and port, or to accept only from a specified IP and a specified port. After the connection has been accepted, the server starts receiving packets. UDP receive has four ports, and they are the same as the ones in TCP receive component. UDP multicast receive represents a server. The UDP multicast receive block receives multicast data over a UDP network from a remote device and lets you alter basic settings for the receive socket, multicast IP address, and multicast port. The port layout of this component is the same as in the case for other previously mentioned receive components. Now, let's walk through an example where we simulate a client on a Hill device while the server runs on the PC using an external Python script. For that, we are using a UDP send component. In this case, the IP address is the address of the client, and the destination IP address is the address of the server, which is our PC. Both the length and data signals are added to the schematic as SCADA inputs, and the data is packed using a C function block. After we compile the model and open the SCADA panel, we can define all the inputs and monitor the output called status. The status will show how many messages have not been sent for any reason. If length remains 0, no message will be sent. The data is defined through three text box widgets. The numbers we type in will create a message which will be sent from the Hill device to the PC after we start the simulation and run the external Python script. Of course, if your application requires communication with clients and servers on different local send and receive ports, You can achieve this by including multiple instances of UDP send, UDP receive, and UDP multicast components. Please note that flexible Ethernet communication isn't available on Virtual HIL or Typhoon SIM, as they require real-time interaction between the message sender and receiver. When using a non-real-time environment, inputs to this component will be discarded and outputs from this component will be zeroed. If you want to learn more about flexible Ethernet communication or other features of the 2025.1 software release, please follow the links in the description below. Thanks for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL.Academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.